Ammonium gram-negative Neisseria. Streptococcus looks like a chain. Staphylococcus is grape-like. This is Staphylococcus aureus. Everybody knows. This is Streptococcus agalactia. We will talk about that. Pregnant woman at 35 weeks have to do a screening test because otherwise it will cause newborn baby ammonium and meningitis. Tetrade, we mentioned about 4 coccyl stacked together like a square. Micrococcus laetus is tetrade. Succinate, 4 of the coccyls stacked together. More. Most of the bacteria is log shape. We call it a bacilla. Some of the bacteria looks like a logs, but also looks like a coccyl. We call it a coccobacilla. Some of the bacteria looks like comma shaped. It's a vibrio. Vibrochloria widely existing in the jellyfish and in the deep ocean marine the seafood products. If you get contaminated, what will happen is dehydration. You will lose 10 liters of water in about like 2 hours. So the treatment will be, instead of immediately using antimicrobials, we have to do the rehydration. Campylobacter jejuni, spiral-shaped sphaerium. We will mention in our last section, this is a major pathogen in poultry meat. I mentioned this. Leptospira interrogans, it's a spiral sheath, hook shape. So what is this one? They use a microscope, dark field microscope. Can you see the background is dark? It's a bacterial showed up. So that's very interesting. Couple of slides talk about that. Okay, this section we are done. We're going to continue to talk because of the snow. We canceled a couple of classes. We're going to go ahead to do. Okay, bacteria grow. This section is important. Lots of things we can talk. Okay. Binary fission is bacteria grow. Bacteria grow is 1 become 2, 2 become 4, 4 become 8. That's called a binary fission. So basically, 1 become 2, 2 become 4, 4 become 8, 8 becomes 16, 2 times the power of n. That is called binary fission. And you look at the slides, it's very simple. DNA exactly the same transfer from the mother cell to the daughter cell. However, we know it's never going to exactly happen because the mutation will be happen. This is look like you or looks like your parents, but not the same thing. Not the same face. It's the same for the bacteria, same thing for the bacteria. That's called the binary fission. Now we want to talk about various important terminology we already mentioned. Generation time. What is the generation time? Is doubling time, which means how long it takes to make 1 become 2, 2 become 4, 4 become 8, 8 become 16. That's called the generation time. Also, we call it equals doubling time. From these slides, you will see why we need to do acid-fast stain. I said even less than this. Microbacterial tuberculosis, 1 cell become 2 cell, 12, 24 hours. So that took 2 weeks to get a confirmation. E. coli, why it is a good lab bacteria strain, the doubling time is very short, every 18-20 minutes. Therefore, it becomes a very important bacteria growth curve. First of all, bacteria growing is not linear. This is the first thing you need to know. Does not mean 1 hour is more than 2 hours, 2 hours more than 3 hours, you grow there forever. No. It's not linear. It's a curve. There are certain stages. Okay, a bacterial growth curve, when you draw it, the first thing you make sure you label x-axis and the y-axis. X-axis is time. Lots of the time it is using second or minutes or hours. Depends on the different type of the bacteria. And the y-axis is the population, CFU per ml or cell per ml. Now we talk about the stages. What are stages? Looks like this. At the beginning, especially moving to a new environment, the bacteria need to go through a preparation called the lag phase. At this moment, they're basically accustomed from the genetic standpoint to suitable for the new environments, so not much population growth. Once they are accustomed to the environments, they're going to grow dramatically. This is called log phase. At a certain stage, in a bacterial media, they are using bacterial media as nutrients. At the same time, they will generate waste. And the waste, most of the time, is a toxication for the bacteria. So at a certain stage, they will reach a balance, which is the number stay the same. We call stationary phase. And finally, the nutrients is gone. More and more toxication is accumulated, the bacteria are going to die. This is called death phase. Every single bacteria in a new environment, they all have a specific growth curve. Today we talk about AI technology, we talk about the machine learning technology. This comes out with a new concept, a new discipline of microbiology called mathematical predictable microbiology. That's a different discipline. In our lab, we're using some existing model to see the reduction growth in different food products. We don't go those deep, design the programmer, but I just let you know, this curve could come out of lots of the ideas. So for example, if the bacteria use antimicrobials, we say it's inhibit bacterial growth. What this means? Inhibit, which means they still stay there. They're not killing. Eventually they will grow. Their lag phase is increased like this, and eventually they will grow like this. For example, if we are using lactic acid, so if you buy a hot dog, you look at the label. They usually prepared by potassium lactate, acetic acids, or those antimicrobials, and they have a shelf life time. Is that right? They're not going to say you're can eat that forever, because it's only inhibit the bacteria, and the bacteria is still there. But if you use antibiotics, let's say they give you a pill of amoxicillin, you're going to kill bacteria. What that means kill? The bacteria not even go to log phase and stationary phase. They died at the log phase. Okay, that's called the log phase. That's called killing bacteria. Some of the antimicrobials, especially for gram-positive bacteria, they are more effective at the log phase. Because at the log phase, they are dramatically synthesize peptidoglycan. And the peptidoglycan is a major structure for gram-positive bacteria. Okay, that's something you need to know. So, very typical microbial growth curve has lag phase, log phase, stationary phase, and death phase. Okay, next one. What are the factors affect bacterial growth? First thing first, the pH. What is pH? pH equals negative log concentration of proton. And the range of the pH is 0 to 14. At the pH 7, we call it a neutral pH. So I'm going to give you some of the questions. Do you know? Which one is close to 0 pH? Our battery acid. That's the reason the old battery has to recycle. You can't just throw away in the trash can. Although you always do that, but toxication because it's very acid. What is a pH 14? Very alkaline environment. That's 1 mole sodium hydroxide. What is our stomach acids? Our stomach is very acid. Bacteria want to survive, they must be battering this first defense system. Stomach acid around pH 1 to 2. What is our distilled water? You buy a bottle of water. You think it's pH 7? No. Most of them pH around 5.5 to 6.0. Light acid. How about the chlorine solution? When you buy a bucket of chlorine solution, Corax from the markets, what's the pH? This pH is around 12. A little bit alkaline. And we know pH is important. So in the bacterial media, lots of the time, we have different type of the pH indicator. For example, neutral red. For example, phenol red. And the phenol red at a pH less than 7, it is yellow color. And at pH more than 9, usually it is a cherry red color. Because you know alkaline is generated. Those are pH indicator. Okay? So here you can see what's a pH. pH is important for bacterial growth. Majority of the bacteria grow at pH 7, neutral, relative. Below pH 4.0, lots of the pathogen will not grow. Below 5.0, eastern modes will dominate. Based on the pH classification, the bacteria could, microorganisms could be categorized as acidophiles, like fungi, pH 0 to 5.5. Neutrophile, most of the bacteria, pH 5.5 to 8.0, alkaline phials, 8.0 to 11.5, like Bacillus, Micrococcus, and Pseudomonas. So that's a classification of the pH. pH is also important for bacteria to survive. Bacteria don't like the acid environment. They need to repel it. Lots of the times they exchange with potassium or magnesium, all those things. Now, very important thing I want to mention. In the food industry, acid resistant is a challenge. And I can tell you, what happened? United States have a regulation called HACCP for the meat products. One of the important things is using antimicrobials. So people using antimicrobials all the time. They're using lactic acid, citric acid, acetic acids. Now what happened? Those are the processing. Only you inhibit bacteria or killing certain bacteria. You're not going to kill everything. Then what happened? You keep doing it. Those bacteria become acid resistant. Once the acid resistance happens, what will be generated? They will generate a problem called cross protection. So which means if you have a beef steak You spray it with acid all the time. If there is a bacteria there, let's say E. coli 157H7 there, they will become acid resistant. And you go to do a cooking process. Generally, 65 degrees Celsius can kill it. Right now, you may need 70 degrees Celsius. Then using high temperature, what will cause a problem? The texture will cause a problem. Is that right? Because the beef, we talk about the juiciness, we talk about the flavor, we talk about the tenderness. Nobody want to order a very well done beef steaks because it's too tough. You cannot bite it. So that's a problem. And always have the balance between that. And so far, there is no good solution for that. The only thing what people can do is preparing 2 to 3 different types of the antimicrobials, because they do the alternative using, they could prevent the acid stress. Question?
Is it kind of like when you're sick and you start taking steroids but then like stop?
Yes.
So it just becomes resistant?
Yeah, become more resistant. Yeah. So that's kind of thing very interesting when we talk about like acid resistant. Temperature. We're gonna finish today. Then after talk about temperature. Bacteria has a minimal, maximum, optimal temperature to grow. Okay, based on the category. That figure looks like complicated. So let's talk about that. Majority of the bacteria is mesophile. Like the bacteria in our skin, Staphylococcus aureus, 20-45 degrees Celsius. I remember it very well. The range of the temperature growth, the mesophile. They can grow very high temperature. So in the food industry, they grow E. coli in 42 degrees Celsius to do the rapid testing, because the mild heat will let them grow dramatically. Some of the bacteria, they survive in a they survive in a cold environment. We call cyclotrophs. Cyclotrophs, the bacterial growth range is 5 to 15, 0 to 35 degrees Celsius. Which bacteria is that? Listeria monocytogenes. This is the reason you heard about the news all the time. Listeria monocytogenes is contaminated with hot dogs. Even the vacuum packaged hot dog in the refrigerated temperature, because it can grow at a refrigerated temperature. So always keep in mind, the refrigeration will slow down certain bacterial growth, but does not mean for everything. Lots of the pathogen and the sporage bacteria, such as Pseudomonas aeruginosa, can grow at a refrigerated temperature also. That is called cyclotrophs. It's a big challenge for the food and microbial safety industry. In the deep ocean marine, in the Antarctic area, you have something very cold can survive. That is called cyclophiles. This is we call environmental bacteria, normally not exist in the lab. Some of the bacteria can survive in the heat environments. Let's say bacillus. That's why we call it a thermophile. They can grow 55, 85 degrees Celsius. Some of the bacteria can survive extremely high temperature, even more than 100 degrees Celsius. That we call hyperthermophile. Which example is hyperthermophile? Is Geobacillus. Geobacillus is using for, we call it quality control stream. This is used to testing autoclave. We want to make sure the autoclave or high pressure cooker is working. Because if the Geobacillus there still survive, which means the temperature does not reach 121 degrees Celsius, they can survive up to 113. What else we can see hyperthermophiles? Yes?
So, you know like how they have to do like pressure cooker things like canned food? Is that like the temperature that you kind of have to reach so you know that it won't grow bacteria?
Yes.
Okay.
But another thing, in the West Virginia, the regulation is a pH. The pH has to be less than 4.0.
Okay.
That's a good topic. That's called acid foods. We will talk in the exam too. Folks talk about cross-training. Lots of things we can talk. That's a very good question. Hyperthermophiles, there's one place in the United States you can find it. Where? Did you ever go? Yes.
Yellowstone?
Yes, Yellowstone National Park in the hot springs. You will see a lot of those wild bacillus. It's a thermophiles. Now, what they do you know? People get those strains, isolate their enzyme to do lots of biotechnology development. You know PCR, lots of you. What are the major components we need to do PCR we need to using? Is Taq enzyme, is that right? PCR can go in through more than 100 degrees Celsius or 94 degrees Celsius cycle. Taq enzyme, where it goes? Thermophile bacillus. That's the first time they get it. That's an enzyme which is coming from the hyperthermophiles. And lots of the thing they can get, even in a cyclophiles, in a very cold environment, even freezing environments, they could get it. And once they get it, what happened? They get an enzyme. They can do lots of the development, know the sequencing, know the biotechnology function, all these things they can do. Okay, that's it. These things, if you think about, there's a lots of the things. We call it a bacterial diversity. There's a lots of things we can talk, extended to different science area. Okay, we're gonna finish here. We will spending a lots of time talk about water activity on Thursday. That will be spending at least 10 minutes to talk about that concept. That's the most difficult one to understand.